Most software projects begin with a burst of optimism and a bulleted list. We rely on high-level feature requests because they get stakeholders nodding, secure rapid agreement, and let us kick off the work quickly. But that high-level language creates an illusion of simplicity that masks immense technical complexity. The iceberg matrix illustrates the problem. Above the waterline sits a simple client request, a user video feed. But look underneath. That single feature secretly demands dozens of hidden engineering realities: unstated edge cases, API security, load limits, and error handling. If your team only discovers these constraints late in the development cycle, the outcome is highly predictable. The budget evaporates, and the underlying architecture collapses under the weight of unforeseen edge cases. Features are excellent for gaining project buy-in, but relying on them as a construction blueprint guarantees systemic failure when the software meets the real world. The traditional engineering countermeasure to this ambiguity is to slam on the brakes. You pause all development to write an exhaustive 100-page requirement specification document up front. There is a core benefit to this rigorous approach. It gives the development team high clarity on system constraints and establishes a perfectly bounded, testable scope. But the trade-offs are severe. You incur massive time delays and exorbitant costs before a single line of code is ever written. Worse, it ignores the risk of emergent needs. Market demands and user expectations change so rapidly that by the time a rigidly specified system is actually built, it is often obsolete. So chaotic feature chasing fails, and paralyzing specification fails. Modern teams have to learn how to differentiate between what to lock down tightly and what to leave flexible. Let's clearly separate these two concepts. Structurally, a feature is just a promise of business value. It is usually framed as a specific action that delivers a result to an object within a short time frame. This flowchart shows the inherent flaw in that promise. A feature only describes the happy path of a user succeeding. It completely ignores the tangled logic tree below it: how the system fails, how it recovers, and how it scales under pressure. A requirement, on the other hand, is the rigorous translation of that feature into a binding, unambiguous, and testable contract for the engineering team. The process of writing requirements forces stakeholders to confront conflicting needs and make difficult trade-offs. It deliberately slows down your initial momentum to ensure accuracy. A feature's job is to secure the project's funding. A requirement's job is to ensure the project actually functions. To avoid both analysis paralysis and chaotic rework, cross-functional teams have to optimize the return on their planning time. We can map that using this chart, the Rigor matrix. The y-axis represents business criticality, and the x-axis represents requirement volatility. Look at the top left quadrant. These are your enduring requirements, the non-negotiable core of the software. This includes fundamental business rules, security protocols, and legacy system constraints that will rarely change. Spending heavy upfront analysis time to lock down these enduring requirements establishes a resilient architecture, one that prevents you from having to do total system rewrites later. Identifying and isolating this non-negotiable architectural core is the highest ROI planning activity your team can perform. But then we have the bottom right quadrant, volatile requirements. These are the fluid elements of a project, like user interface details, new market adaptations, and open-world user interactions. Attempting to rigidly specify these volatile elements in advance is a mistake. It only creates a false sense of security in your project plan. When real-world users interact with the system differently than you predicted, they will shatter that rigid planning. You end up scrapping heavily documented work and wasting massive amounts of effort. To survive contact with the market, volatile requirements must be deliberately left flexible. You have to push the detailed specification of these elements to the last responsible moment. Ultimately, features and requirements are not opposing philosophies. They are sequential stages in a translation funnel, and bridging them requires disciplined management. This scorecard outlines the translation protocol, the criteria required to transition a vague feature into a bounded requirement. By checking these off, you identify the exact source of the request and define its quantitative limits. Enforcing numerical boundaries removes the ambiguity of adjectives like fast or secure that plague high-level feature requests. Next, you define the failure exceptions and establish strict, testable criteria. This ensures the engineering team knows exactly when a task is officially complete. This rigorous translation protocol is the mechanism that successfully aligns business ambition with engineering reality. If you are a visionary product owner, you have to prioritize features to maintain market momentum and keep users interested. But your trade-off is this: you must explicitly allocate budget and schedule buffer for your engineering team to conduct requirement solicitation behind the scenes. Without that time, the product will collapse under load. If you are a tech lead, your mandate is to protect the codebase by forcing the business to define bounded, testable criteria. But your trade-off is accepting that volatile requirements will shift. You have to design an architecture flexible enough to absorb UI tweaks without demanding a brand new specification for every minor adjustment. Features are what sell the software to the market. Requirements are what allow it to survive contact with reality. Optimize for the first, but rigorously engineer for the second.